Okay, so I know I got cut off a little bit on the previous example, but go ahead and try that. And like I said, you should get 10, and that was on 11-14. So go ahead and let's move to the next page, and let's look at 11.15. And I'm going to talk a lot of concepts as I work this one problem, and then I'm going to work another problem. So hopefully we'll get 2 problems done during this time. So it says a loudspeaker emits a sound whose intensity is measured to be 10 to the -4 watts per meter squared at a distance of 3 meters away. So let me write that down. We know that the intensity, let me make this a little bit bigger, by the way. Whoops, too big. Okay. And so I know that the intensity is 1 times 10 to the -4 watts per meter squared. And then we are at a distance of 3 meters away. So here's the thing. Anybody that is 3 meters away from that speaker, whether you're to the right of it, to the left, if you're to the right, left, top, bottom, or even like up in space up here or down below, if you're 3 meters away, you perceive a sound of an intensity of that. If I wanted, I could go ahead and convert that to decibels. But remember, we don't want to be in decibels. We want to be intensity in order to do any math at all. Okay, so remember, I'm going to do this again. No math in decibel scale. All right, you always want to be intensity, watts per meter squared, before you do any math at all. Okay, it says how far from the speaker must you stand in order for the power level to drop to 67 decibels. Okay, so we want, for the level to drop to 67 decibels. If we did convert 10 to the -4, I think in the previous example that would be 80 decibels. So we want it to drop to 67. All right, so what I'm going to do is, here's the thing, intensity is equal to power all over area. Now this is the output of the source. Okay, so the source could be a speaker. In this case, it is a speaker. All right, so that's the power output of the source. Now here's the thing. As you walk further away from the source, the power output stays the same. This is typically a constant. All right, how do you change the power output for the source? Simply turn the volume up or turn the volume down. But if you turn the volume, if you put the volume on and then you simply just walk away, you're not changing the output power of the source, but it seems less intense because this is changing. All right, you could stick your ear right up against the speaker. Someone could walk away from the speaker. You guys are both going to have the same power output from the source, but the person with their ear in the speaker is going to hear a lot more intense sound because of the relative closeness. All right, so because power is a constant, watch what I'm going to do. I'm going to say intensity at spot 1 equals my power all over my area at spot 1. The reason I don't need to put a subscript right there is because power doesn't change. So I'm going to rearrange this equation to say power is equal to intensity at spot 1 times area at spot 1. Well, if that's a constant, I can say, hey, my intensity at spot 1 times my area at spot 1 equals my intensity at spot 2 times my area at spot 2. We already know my intensity at spot 1. That's where I'm at. The area at 1, we don't quite know that. But remember, area for a sphere is 4 pi r squared. So what I'm going to do is I'm going to plug that in. So I1 times 4 pi r1 squared equals I2 times 4 pi r2 squared. Notice 4 pi and 4 pi are the same. Now, I know that given, I know R1, 3 meters. We are trying to find out how far or where do we need to stand from the speaker to get it to 67. Now here's the thing. We never want to use decibels. So I'll give you a hint. Whenever you see a decibel in a problem, I would convert it to intensity right away. I did not do it here, but we can. So the intensity of a 67 decibel sound will be I naught times 10 beta over 10. All right, so what I'm going to do is I naught, remember that's the threshold of hearing. That's the smallest possible intensity that we can perceive. That's always 1 times 10 to the -12th watts per meter squared times 10 and then 67 divided by 10. So what I'm going to do is I'm going to punch my calculator. I'm going to say 1 times 10 to the -12th times 10 raised, I'm going to put this in parentheses, raised to 6.7 because 67 divided by 10 is 6.7. I'm going to get 5.012. So the intensity is 5.012 times 10 to the -6 watts per meter squared. So now this is my intensity at my new spot. I'm going to call that I2. So what I'm looking for is I'm looking for that. So basically R2 squared is equal to I1 over I2 times R1 squared. Then I could square root both sides to get rid of R2. And so R2 is equal to my initial intensity, which is 1 times 10 to the negative 4th watts per meter squared, divided by my new intensity of 5.012 times 10 to the negative 6 watts per meter squared, all times my original distance, which was 3 meters, that is squared, and then I'm going to square root that entire thing. So when I plug all that in and square root that, I should get an answer of 13.4, so 13.4 meters. Okay, and so let me reiterate all we did right there. Originally, when you were standing 3 meters from whatever that speaker output was, you were perceiving a sound of that intensity, right? And I believe that that intensity is about 80 decibels. That's how you would perceive it, all right? You can't, let's say you can't control the speaker. The speaker is locked in and you can't do anything about it, but you can't stand 80 decibels. You want to go to 67 decibels. So all we did was we took 67 decibels and we got the intensity of a 67 decibel sound by simply plugging into this formula. I will give that to you. All right. And so what can you do? Hey, if I want it to go down, I walk away from the source. And as I get further and further away, it'll seem less loud. Are you changing the volume of the source? No. You are just perceiving it less because your area is getting bigger. The area of the sound is further bigger, so the energy spread out over that energy per unit area is smaller. All right. So what that means is I would have to be standing at 13.4. So if I go back up here, I would have to be at a distance of 13.4 away from the center in order for me to perceive a 67 decibel sound. So what's the total distance I would have to walk away from the speaker? 13.4 minus the original 3 meters I was standing at. Now, it's not asking for that. It's just saying how far from the speaker must I stand? I would have to stand at 13.4 meters. All right, so let's try another problem. This is number 3 on page, I believe it's page 1124. It says a teacher insists that the overall sound level in his classroom, now it says sound level, remember sound level is decibels, not to exceed 61 decibels at his location. There are 20 students in his class. If each student talks at the same intensity level, and they all talk at the same time, so basically they're going to add together, what is the highest sound level at which each one can talk without exceeding limit? Now what we're going to do is we're going to make the assumption that they all talk at same level. Okay, they're all talking at the same level. Now, remember, we never want to deal with the decibel scale when we do math. So the first thing I'm going to do is I'm going to find the intensity of a 61 decibel. So the intensity of 61 decibel would be I naught 10 raised to the beta over 10. So I is equal to the threshold of hearing, which is the lowest sound that we could possibly perceive, right? Multiply that by 10, raise that to 61 divided by 10. All right, so if I punch in my calculator, I get 1 times 10 to the negative 12 times 10 raised to the 6.1, and I get 1.26. I'll say 1.26. 1.26 times 10 to the negative 6 watts per meter squared. So what that means is the intensity of a 61 decibel sound is that. So the teacher does not want to perceive an intensity higher than that. Okay? Now, if we are going to assume that there are 20 students in this class and each can talk with the same intensity, how do I find the intensity of each individual student? This is as a whole class. Whole class. How do I find it for one individual student? What I can do is I could take that intensity, the intensity of the class, and divide by 20 students. And this would give me the intensity of one student. So I'm going to divide that by 20, and I get 6.29. 6.29 times 10 to the negative 8th watts per meter squared. So that's the intensity of one student, but it says at what's the highest sound level? So I want to go back to decibels. Sound level is the decibel level scale. And so the equation beta is equal to 10 log of I over I naught. The I is, this is for one student. This is one student right there. I'm going to plug that in. So 10 log of one student. The intensity of the one student is 6.29 times 10 to the negative 8th watts per meter squared. that is all over the threshold of hearing, which is 1 times 10 to the negative 12th watts per meter squared. Those will cancel. If I plug that in, divide that by 1 times 10 to the negative 12th, then do log of that. All right, and then multiply by 10, I get about 48 decibels. So if each student talked at 48 decibels and we had 20 students, then the teacher would be able to perceive 61 decibels of sound. Okay, so this was what it would be. So if you took 48 times 20, you would not get 61. So remember, do not use the decibel scale to do math. Always be intensity. Always use this equation to get intensity. From there, you can do any type of math that you typically would do. Then we could plug back into the original equation to solve back for decibels. All right, so here's what I want you to do. On a separate, so do this one in your notes packet. Sorry, I should have told you that. Actually, yeah, on a separate sheet of paper, what I want you to do is try problem number 4, which is on the next page. And I'll give you a couple of hints for this. So just on a separate sheet of paper, you're going to turn this in to me on tomorrow. Number 4, it says the human eardrum has an area of this. What is the sound power received when you hear that intense sound? So basically the minimal possible perceivable sound is that. So we know power is equal to IA. You know the intensity, and then this is the area of your eardrum. So that's the amount of power you're perceiving. Okay, question B, what is the sound power at the eardrum for a conversational speech, which has a sound level of 65 decibels? So you're going to want to convert that to I first. Then power is equal to IA. You're still going to assume that your area of your eardrum is not changing because someone's talking differently. So that area is going to be the same, but the intensity is going to be a 65 decibel sound. And the last one, C, what is the sound power at the threshold of pain? Basically, the threshold of pain is where the sound level is so high that you can't do anything but cringe and hold your ears. You might have heard of police or like mob control using this really loud sounds to try to get people to stop doing things. So what I got to do is take 140 decibels, convert that to intensity. Power is still equal to IA. This is the power your ear is receiving. The intensity is right there, and then the area of your eardrum is not changing. So try this on a separate sheet of paper and turn this into me tomorrow.